Hello and welcome to the JK Feather Ranch channel. I don't have a car to work on today, but I do need to do some work on my gate. I put up this archway a couple years ago now to give me some light when I come home at night, but it's only supported by 2 points in the ground, so it's always leaned a little bit to the side. It's a little flimsy and it might have gotten a little worse over time. I poured these 2 cement pads a while ago with the intention of running a piece of wood diagonally from here to brace the structure, but I haven't got around to doing that yet. A problem I knew I would run into is that in order to mount a piece of wood to a flat pad, I would need a bracket that goes diagonally, and the only ones I could find at the store go straight up and down. So I figured I would have to make my own, which is what we're going to do today. Let's get started. The first thing I need to do is figure out my angles and measurements. I remember from high school math class that there's a relationship between the sides and angles of a triangle, and if you know some of them, you can figure out the rest. I don't remember exactly what that relationship is, but a quick Google search for a triangle calculator means I don't have to. I know that my post is at a right angle to the ground, or at least that's what I want it to be once my brace is installed. Right now, it's kind of doing whatever it wants. The distance from the center of one cement pad to the center of the other is 46 inches, and I want my brace to meet the post 6 feet or 72 inches above the ground. Plug those numbers into the calculator and I get an inside length of 85.4 inches for my brace, with angles of 57 degrees at the bottom and 33 degrees at the top. Now all I have to do is make that happen. I'll be making my bracket out of 4-inch by 1/8 inch wall square steel tube. This will give me about 1/4 inch of play on each side in case my math or my measurements didn't come out quite right. I want it to be 8 inches on the longest side, so I'll mark it and cut it to length. And now for the tricky part of cutting a 57-degree angle with a saw that only goes to 45. I actually want a 33-degree angle on the gauge, since what it shows as 0 is actually 90 degrees in relation to my workpiece. 90 minus 33 gives me the 57 degrees I want. Right about here, my saw decided it had enough of the long flat bottom portion and tripped the breaker. I finished the cut with an angle grinder. This added the extra step of grinding the face smooth, but at least it felt like I was still making progress. Now it's time to mark off my bolt holes. Using a square, I made marks 1 3/8 inches from each edge, and then followed those lines 2 inches down and another 1.5 inches down past that. By connecting the dots, I have an even pattern of 4 bolt holes that will fit 1/2 inch bolts and washers without hitting each other. Then it's just a matter of drilling out the holes. Notice my drill press doesn't have enough travel to complete the entire hole in one go, so I have to raise the table and then drill the bottom section. After using an angle grinder to clean up the outside, and a round file to clean up the inside, the top half of my bracket is complete. For the base, I'm using 1/8 inch steel plate. I needed it to be 8 by 6, but I could only buy it in 8 inch squares, so I had to trim off the extra 2 inches. Ideally, you'd use a bandsaw for this, but I don't have one. So I threw a metal cutting blade on my old miter saw and hoped for the best. So far, it seems to have held up fine. I need to drill holes in the base in order to attach it to the pad, setting them in 1 inch on the long side and 3/4 inch on the short side will allow a 1/2 inch bolt and washer to fit without interference. The last step, of course, is to drill out the holes and weld both sections of the bracket together. I'm just using a cheap flux core welder I got on sale for $100 at Harbor Freight, which I would highly recommend if you're even remotely interested in making projects out of metal around the house. I'm sure mine has paid for itself multiple times over by now. I should point out that this is not a welding video, and in no way do I claim to be a good welder. But there are plenty of other videos out there to show you how to do it, and so far all my welds have held up fine, even if they're not the prettiest. Using flux core does require the extra steps of removing slag and grinding off weld spatter. With everything cleaned up, the bracket is finally ready for paint. My go-to product for applications like this is truck bed liner from Rust-Oleum, as it seems to hold up well to constant exposure to the weather. Remember to coat the inside of the bracket as well, so it doesn't rust out from the inside. I apparently didn't film it, but don't forget to paint the underside as well once the top dries. While the paint dries is a good time to prepare my wood. Since the top requires an angle of 33 degrees, which is sharper than my saw can cut, I can't just subtract that from 90 and cut regularly. This might not be the safest thing to do, but I set the saw to 33 degrees, lined up my wood the wrong way with the end grain against the fence, and used the sliding function to make my cut. The result is a clean, smooth 33-degree angle. Since 85.5 inches is the length of the inside of my triangle, I want to measure from the inside edge of my angle and make my second cut. The result is a board that is approximately 46 inches away when held against the wall at the proper angle. To mount my bracket to the cement pad, I'll be using these lag shields. You insert them into a hole, and as a lag bolt is screwed in, they expand and lock themselves in place. After marking the locations of all 4 bolts, I used a rotary hammer with a 3/4 inch bit to make my holes. The electrical tape around the bit lets me know how far down I need to drill. A shop vac and an air compressor work great for removing dust from the completed hole. Perhaps blowing it out into the vacuum hose would make more sense. When inserting a lag shield, make sure it expands sideways from the outside edge of the cement to prevent cracks. Tap it in place until it sits just below the surface. Insert the bolts and get them started. And tighten them down. They will get very tight as the anchor expands, so an impact wrench is quite helpful. Set the post into position where you want it and clamp it into place temporarily while drilling the bolt holes. It's best to drill halfway through from one side and then halfway through from the other so that one side doesn't end up off-center. Insert the 4 bolts. And tighten them down. To attach the top sections together, I'll be using carriage bolts. I need to create a recessed area for the bolt head perpendicular to the back post but going through the front one at an angle. A spade bit slightly larger than the bolt head will allow me to accomplish this. It's slow going as my small cordless drill almost doesn't have enough power for this size hole. Since the tip of the spade bit already gives me a nicely marked center, I can drill it the rest of the way through with a regular 1/2-inch bit. I had to remove the clamp and separate the 2 pieces to finish drilling through the second post. After lining the holes back up, I could push the bolts through. And tighten down the nuts. The 2 posts were pulled nice and tight with no gaps or misalignment. All that's left is to repeat the process on the other side. After putting up braces on both sides of the archway, it's a lot sturdier. It still has a little bit of movement side to side, which really isn't a big deal, but it does not move at all front to back. And perhaps most importantly, it stands up straight. I hope you enjoyed this video and maybe even learned a thing or two. If they don't sell the part you need at the store, there's usually a way to make it yourself. If you did find this useful, don't forget to like and leave a comment below, and please subscribe to our channel for more videos.